Today we're going to be covering acid-base nomenclature. So acids are going to be based off of their anion, which is going to be the second element or compound that appears within the actual formula of my acid. For our purposes, all acids are going to start with H as their cation. Even though hydrogen is normally considered a non-metal, within acids, hydrogen acts as if it was a metal. It has metallic characteristics and it gives up its electrons completely, therefore making it a cation. This is an unusual circumstance, so acids have a particular naming system. We have rules again based off of my anion, and so if my element if my anion is directly off of the periodic table, meaning that it is just a simple element, then all I have to do is add the prefix of hydro and add the suffix onto my anion of ic and then acid at the end. So what this would look like, we have HCl. So H, we're starting off with hydrogen, which would make me an acid. Then I have Cl, who is just directly from the periodic table, that's chlorine. Since I have an element from the periodic table bonded with the H, I am going to have the prefix of hydro. Same place that I would add IDE, I'm going to change that suffix to ic. So this is going to be hydrochloric, and then I need that word acid on there. If my anion is not directly off the periodic table, if instead my anion is a polyatomic ion, I am going to change my suffix for my polyatomic ion, but I'm not going to add that prefix of hydro. I still need that acid at the end, okay? But I have rules for how I am going to change the suffix of my polyatomic ion. So if my polyatomic ion ends in 8 in its normal state, I'm going to change it to ic. If it ends in ite, it will change to us. How I like to remember this is I ate something and I went ic. Okay? If you can remember that, then you can remember that the other one is going to be OUS. So here we have a leading hydrogen, which would make me an acid, and then I have ClO3. ClO3 is chlorate. So chlorate, 8 turns to ic, and then I just add acid. So this is chloric acid. ClO2 bonded with hydrogen. ClO2 is chlorite. Ite goes to us, so this would be chlorous acid. My bases are not as complicated as my acids. My bases are going to be anything where I have my anion be hydroxide. And we're just going to follow our normal ionic nomenclature rules for bases. I don't have to tell you that it's a base for this class. If it's bonded with hydroxide, it's safe to assume that it's going to be a base. But I don't have to actually tell you that it's a base within its name, unlike with my acids. So here I have an example, NaOH. Na is going to be sodium. It is in the first two columns, so I don't have to give you an oxidative state. And then OH, hydroxide, and this would make me a base. Sodium hydroxide is a base.